find the sum of each arithmetic series. So again, remind me, what is a series?
A series of a sequence?
Impressive.
So what makes this a series versus a sequence? No, you can have a final number in a sequence. There's plus signs. So in a sequence, you would just have commas, right? In a series, because we're adding them all together, we have plus signs. Now, what numbers are those? The even numbers, okay? So I could have just easily add together the even numbers from 2 to 100. And that would be the same thing as putting it as a list. Yes?
Yes.
Okay. Because our even and our odd are technically types of sequences because we're adding the same thing each time. Yes? So what is our sum formula? S sub n equals n times a sub 1 plus a sub n
Over 2.
divided by 2. Alright. So now let's think through. You can do this one of two ways. Okay? We know what our a sub 1 and our a sub n are. Our first term is what? 2. Our last term is 100. Okay? So then to find our n, remember that from yesterday, we could use our a sub n equals a sub 1 plus n minus 1 times d. Okay? Our a sub n is 100. Our a sub 1 is 2. And what are we adding each time? 2, right? And then you would solve for n. Or we can kind of think about this through logically. Right? How many numbers are there going to be from 2 to 100 if I'm only going by the even?
50.
50. Alright, so it's going to be my 50th term. Are we okay with that? Yes. But interesting story. Do you want to know like where this formula came about?
The guy who made it.
Yeah, so the guy that made it, he was actually, he didn't have it, proven at this time, but he was, 8 years old, sitting in a math class. Yeah, and he was being disruptive and being kind of annoying, and so the teacher was like, as a punishment, I want you to add together all of the even numbers from 2 to 100. And he was just bam, whipped it out, and then, gave her the answer, and she had to check it. And it was right. It was because, in his mind, he could kind of see the pattern and look at what the sum of those numbers would be. So later on, he's the one that kind of went on to, do a lot of the stuff in sequences and series.
So he was 10 at 8 years old.
Yeah, he's pretty smart.
They keep talking about how I'm going to make a Brian theory.
Okay.
Yeah,
That's
they do.
his last name.
You
So I think he's gonna make it on the problem.
Just another announcement to students going to CB Tech for the trip. You are being dismissed, and you will need to go to the North Bus Loop. Students going on the CB Tech trip, you are dismissed, and you need to go to the North Bus Loop.
Alright, so we have 102 divided by 2 gives us 51. So what is 50 times 51?
2,500.
Never mind.
2,550.
550?
Yes.
Questions on that? Alright.
You use basketball?
No.
Yes.
Alright, so next up, we are looking at sigma or summation notation, which is fun to say. So sigma is a Greek letter, okay? It kind of looks like a big E-ish, right? Basically what it stands for is to sum or to add things together, which is why we can use this to represent series. Because again, we are adding all of the terms together in a series. This stands for add stuff together. So we can use this notation to represent a series. So the bottom number is the first number that we're going to plug in. The top number is the last number that we plug in, and the thing over to the side is the formula that you plug into. So like here, we have the sum from k equals 1 to 12 of 4k plus 2. So first I plug in 1 into the 4k plus 2. Then we plug in 2, then we plug in 3, and we plug it in all the way until I get to 12. And so you would get a series that looks like that. So again, it's just kind of a different notation that you could see. Questions on that? We'll look at an example with it. We have the sum from k equals 4 to 18 of 6k minus 1. So, again, there are one of two ways that we could do this. This is just a multiple choice question. So that's why it's A, B, C. Sometimes it throws people off. So, the first way that we could do this, alright, is just to plug all of those numbers in and add them in our calculator. So what number are we plugging in first this time? 4. So we have 6 times 4 minus 1. Then we would add, and we would plug in 5. Then we would add, and we would plug in 6. And so forth. Yes? Well, it's going to be a lot of numbers. We have between 4 and 18. So let's look. What is 6 times 4?
24.
Minus 1.
23.
Cool. 6 times 5? 6 times 5, sorry.
6 times 5. Oh, 30.
Minus 1 is?
29.
Okay. 6 times 6?
6 and 6, 36.
Minus 1 is?
35.
Okay. So, what are we adding each time there? 6? Are we okay with that? So, if I know that we're adding 6 each time, what type of series is this? Arithmetic, which is when we add stuff. Yes? So, instead of then plugging all the rest of this stuff into our calculator, right, we can use our sum formula. Yes? Which is a little bit easier. You'll get the same thing either way. So, if you would rather just plug in 4 through 18 and add them all together, have fun. But we're going to use the formula. So that is our n times a sub 1 plus a sub n divided by 2. Okay? Now, here is kind of, we got to think a little bit. How many numbers are we adding together from 4 to 18? No.
16. 15.
There we go. Right? Because, okay, so how many numbers are between 18 and 4? 14, right? So, like, we could do 18 minus 4 gives us 14. Yes? And that's how many numbers would come after 4. Agreed? To get to 18. But we also have to plug in 4. So, your n, I'll put it over here. Your n is always going to be the top minus the bottom plus 1. Okay. N is top minus bottom plus 1. So, in this case, our n is going to be 15. Yes? Alright. So then what's our first term? 23. Okay, so be careful because a lot of people want to put the 4 here, alright? But remember that 4 is not my first term. What I get when I plug in 4 is my first term. So I have 23. Which means that what do we need to plug in to find our last term? 18. So 18 times 6 gives us
Calculator.
Well, you have 60, right? And then what is 6 times 8?
48.
So 60 plus 48 gives us
128.
108. And then minus 1 gives us 107. Are we all okay with the math that I did there?
No, not really.
Yes.
How did you get 107? Oh, you subtract on one.
Yeah, so 6 times 18, right? So that's a 10 and an 8. So 10 times 6 is 60. 6 times 8 is 48. So 60 plus 48 gives me 108. And then I have to subtract 1. Because my formula is 6k minus 1. Yeah, I'm just finding the last term. So then we just plug all this in. So what is 23 plus 107 divided by 2
65.
times 15?
975.
975, which is C.
This was the ACT. I would got it right.
Yeah.
Because I would just put C.
Well, there you go. All right, what questions do we have there?
So is 107 the 8 sub 18 or is 975?
So, to get my last term, okay, I have to plug in 18. So 107 is my last term. Okay.
Wait, I forgot. It's
This
sum.
is the sum of adding all of this stuff together from 23 to 107. Does that make more sense? If it just said find the, what would it be? 18th term in the sequence, right? Then your answer would just be 100.